2% is what, Z category? Kevin, go ahead, what's on your mind?
I was just gonna say, like, what percentage of people have an IQ between 100 and 110?
Okay, good. Now, here's the difference between those two questions. We can answer that one. What percentage of people have an IQ between 100 and 110? First of all, can we answer that? Hell yeah, we can. How would we answer it?
That's what we just did, isn't it?
Why? Johnny, go. Why? How come?
Because
How is it like the 80 and the 90 and the 51 and the 70? Go.
Because you have the range.
Because I've got the actual numbers, right? So I can take the 100 and the 110 and convert them to z-scores, and then feed the z-scores into the machine to pop the area out. So what kind of a problem is that?
Forward.
That's still forward, isn't it? What did you ask again? Andrea, go ahead.
You could just pick a percent and say what, like 2% is in which category.
Good, 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 good. Actually, can we get away? Can I pick a different percent? Is that okay, just because this was so close to 2%? Let's do this. Let's use the 90th percentile. Which IQ score has a C in it, is the 90th percentile? Which IQ score would be the 90th percentile? Now, what's given to you here? What's given to you, numerically, what is given to you in this one? Go ahead, Jay. The area, the 90th percent, the 90%. And what question is being asked? Which
percent?
No, the percent's 90.
Okay.
Which IQ? So you see how this is why I call them backwards problems. In these, you have the IQ scores, and you're going for the areas. In that, you have the
Area.
and you're going for the... That's exactly right. It's exactly backwards. In mathematics, they don't call it backwards, they call it inverse.
Right.
But it seems like conversationally, people like the term backwards better. Forwards and backwards, it kind of makes sense. Fair enough? So in other words, you're starting here with what you ended with here. Here you ended up with 2.2%. Now you're starting with 90%. The only thing you got to make sure you do, and that's why I like drawing them when I do these. The only thing you got to make sure you do
So I spent all that
is draw the 90% in the right place. Where's the 90% going to be drawn? What's the 90th percentile mean? What does it mean, 90th percentile? It's a blast from the past, isn't it?
It's the number for a group.
Good. What percentile is the average?
Well, 100.
The 50th percentile, right?
Right, yeah.
Why? Why is the average the 50th percentile?
Because the middle is half. Well, it's roughly.
Yeah, I like the fact that it's half, but which half? This half or this half? What does percentile measure? I'm asking an old question here, I apologize for that. What does percentile measure? The percentage of the data that you exceed, that you are higher than. Remember, you have to go back now. Remember Max and his 85th percentile head girth? Why was he in the 85th percentile for head girth?
Since it was higher.
Because his head was girthier than 85% of kids his age. He was longer than 90% of kids his age. He was heavier. Heavier than 80, longer than 90, and girthier than 85. Whenever you hear percentile rank, it's the percent you're bigger than. So the area, the average is the 50th percentile. So where's the 90th percentile going to be? Over here, isn't it?
Yeah.
Where? Okay, right out there. And I love what you're saying. It doesn't even matter where you put it as long as you put it to the right, because you can fix that right now by going, you know what? That's 90%. You don't have to be exact. This is going to be exact for us. The machine will give us the exact placement of how far out we have to go. As long as you're to the correct side, that's all I'm worried about. It will tell us how far out is how far out enough. So this is like if you guys did it, and I haven't gotten a solution video for you yet, and I apologize. That binomial quiz, how many alarm clocks should you buy until you're 99% sure you're going to wake up? As long as you know it's more than 3, the formula and the technology will show you how many you have to buy to make sure it's more, or to make sure it's 99%. This is 90%. The difference is that was binomial, which means you buy 1 clock, 2 clocks, 3, 4, 5. This you can have sliding scales between. There aren't those discrete jumps. Cool? So the question I have for you guys is, what's that? For 90%. What is that, huh?
Is it 10%?
Well, what would the z-score itself be? Correct, Johnny, this is 10% out here, for sure. But what marker cuts the 90 from the 10? Is it 1? Is it 1.5? Is it 2? Is it 2.5? Is it 3? Linda's got a vote back there. Now, before we take Linda's vote, which I love, by the way, think about how we did the forward problem. Think about the order of things. We started with the IQ score. Then we converted it to a z-score. Then we put the z-scores in the calculator and popped out an area, correct? So turn that around. Take the area and do what with it?
Make a z-score.
Make a z-score by putting it in the machine. That's what the backwards is going to do. You have to feed it through the machine first to pop the z-score out. The reason the program is called normal, standard normal, is because you have to be in the standard normal curve. We want this to be IQ eventually, for sure. We want this to be IQ eventually, which means we want it to be 100 and 115 and 85 and so forth and so on and so forth and so on. But we can't jump right to that. We have to be on this curve first with an area of 0, or with an average of 0. So use the machine to get the value that we need for that z-score. Let's do it.